This is example 1 from your myAP questions that are from the College Board. So in this example it says, for what value of k, if any, will this equation be a solution to the differential equation y double prime plus 16y is equal to negative 27 times the sine of 5x. So what we'll need to do here, folks, is we'll need to find the second derivative of the original function. We'll substitute that in and see which value of k will make this true. There's a and b down here, and there's also c and d, which you can't see on the screen just quite yet. But once we do a little bit of work for this, we'll go ahead and see which answer it's going to be. So to figure out what y double prime is, we'll have to take the first derivative, and we'll take the derivative of that again. So now I'm looking at my expression for y, and I know that I'm going to have to use the chain rule here. So this is going to be 5k. Remember, k is just a constant. It can stay out front. And then the derivative of the sine is the cosine. So I'll leave that inner function the same as well, and that's supposed to be an x, not a k. The next part is going to be 8. I have to take the derivative of 4x, which is 4, multiply that by 2, and then the derivative of the cosine is negative sine of 4x. So we'll have to make that notation there. Not great work, but we'll get past it. We'll find the second derivative here. So the derivative of the cosine of 5x is negative sine of 5x times 5. So my leading coefficient here will be negative 25k times the sine of 5x. And then I have a negative 8 here, and the derivative of the sine is the cosine, and the derivative of 4x is 4, so I'll be multiplying the negative 8 by 4. So that's negative 32 times the cosine of 4x. The next part is to take this second derivative and substitute it in. So I'm going to write that work here on the right hand side and continue that vertically. So I have negative 25k times the sine of 5x minus 32 times the cosine of 4x, and then I need plus 16 times y. So I'll just distribute the 16 all the way through, and we'll wind up with 16k times the sine of 5x. Starting to run out of room here. And then the other part will be plus 32. 2 times 16 is 32. And then the cosine of 4x, and that has to be equal to this piece right here. So let's combine some terms. Here I have negative 25k plus 16k, which is negative 9k, and that's the coefficient of the sine of 5x. And I have negative 32 cosine of 4x, which cancels with this one. And remember that that needs to be equal to negative 27 times the sine of 5x. So the sine of 5x's will cancel if we divide each side, and I wind up with negative 9k is equal to negative 27, so k will be 3. Let's go and check our answer choices out now and see if we can find those. So here's our answer choices, and it looks like C is 3, which is the solution.